All right, welcome back, 8th grade. We're going to push deeper into our book on It's in the System. We're going to do problem 2.2. So here we go. All right, we are solving systems by combining equations in the realm of the taco truck lunch. So basically, we worked with one way of solving these systems of equations with working with the equation in the format of y equals mx plus b. Or if you solve for x, you had another type of number that would match up with the y, but still had that final number there. Now we're looking for another way to solve them other than setting the equation equal to each other and other than graphing through this setup for lunch. So we had Pablo and his brother, they together got 6 tacos and 2 drinks and it was $9. And then Jasmine and her brother got 4 tacos and 2 drinks for $7. And so we're trying to figure out how we can work together to get these prices. So here's what we have. Pablo's younger brother, Pedro, used the orders and total prices to find the price of each taco. They didn't know how much everything cost. They didn't tell them. It just said, we want this many tacos, this many drinks. It costs this much. So it says here, when asked to figure out the prices, Pedro said, it's kind of like we did in school with the coins and pouches. Then he made the following sketch, meaning like we could do some crossing out and some combining and comparing. So what I'm looking at here specifically, this is the idea of, first of all, looking at, so this is going to be 6 tacos plus 2 drinks is equal to $9, and 4 tacos and 2 drinks equals $7. Now, if I look at this, the only thing different is 2 more tacos here. It brings $2 more here. So that means that the tacos have to be $1 a piece. So in this case, you can see that if I took the 6 tacos away and the $6 of this away, I'd be left with $3 left over here for the drinks. So if I took away $4, I'd still be left with $3 a drink. So that means that the $3 left over has to be split amongst these 2 drinks, which kind of tells me it'd be $1.50 per item. So it says here, how does this sketch help you find the price of 1 taco and the price of 1 drink? Well, you just kind of have me talk through it, basically because there's $2 more here, 2 more tacos here. That's the way it's got to come together. So let's just take that's what we do for A1. But A2 asks us to find another way to use Pedro's sketch. And let's take a look at that. Another way to look at this is if we actually went through and we cross-canceled everything out, similar to the way we would do those pouches and coins, where we take away things that are all together. So first of all, I see I've got 4 tacos here. So if I took away those, 1, 2, 3, 4, and then 1, 2, 3, 4, I have 2 tacos left. So I have that down here. Then I have these 2 drinks here, take those away, and I have 0 drinks left. And I'm left with an equal sign, and I'm going to take away 1, 2, 3, 4, 5, 6, 7. And I'm going to take away 1, 2, 3, 4, 5, 6, 7. So you'll see that we've got these $2 left. And that tells us, basically, that means that 1 taco is equal to $1. So when we have that, we can take that information and put it back in and solve the situation here. So if I take that, plug it into, let's say, this guy here, that means it's going to be 6 tacos is $1. So I'm going to have here that 1, 2, 3, 4, 5, 6. I have my 2 drinks, and that's going to be equal to 1, 2, 3, 4, 5, 6, 7, 8, $9. So here we go. I'll be left with 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Look at that. I've got $3 and 2 drinks. That means I have to split $3. So the drinks are going to be $1.50. Okay? These are going to be $1, and that brings the drinks equal $1.50. B. Pablo and Jasmine had just started studying the systems of linear equations in algebra. That's funny. You guys did too. They looked at Pedro's drawing and said, we could write that as a system of equations. First of all, it says write an equation that represents the cost of Pablo's order and one that represents the cost of Jasmine's order. Use T for the price of the tacos and D for the price of each drink. All right. Our equations are right here. This is our first one. And so if you see we had the 6 tacos, so I'm going to write 6T plus the 2 drinks is equal to, and there were the $9. So that's going to be 9. And the second one is right in here. And you can see that we've got our 4 tacos. So we have a 4T plus the 2 drinks equals $7. And that's our system of equations for this. All right. What operations with the equations from part 1 match your way of using Pedro's sketch to find the prices of T and D? The operations we use over here, we did kind of like something similar to some subtraction. If you recall, we were kind of like taking things away. So I think it's going to be with subtraction. And why do the operations make sense? Well, let's take a look at what we have here. So if I actually go in and I do some subtraction, I do this here, I do a big old subtraction. If I do a minus sign and I take all this away. So think about this. If I do 6t minus 4t, like we did over, remember we crossed out the 4 there, I would be left with the 2t. Then this comes down, I'm going to be left, these are going to cancel, it's going to be plus a 0, and this is still going to be, it's going to be 9 minus 7, so it's going to be equal to 2. When we do that, we have a 2t equals 2, divide by 2, divide by 2, t equals 1. Look at that, just like we had before. And I can go back in and plug this in, so if I do that up here, it'd be the same thing as doing a 6 times 1, so I would do a 6 plus 2d equals 9, minus 6, 2d equals 3, divided by 2, d would equal, there's that 1.5, the $1.50 in that case, just like we had C. In algebra class today, the next day, Pablo and Jasmine tried to solve the system of linear equations, x plus 4y equals 11, and x plus y equals 5. How could they represent the system with a sketch similar to the one that Pedro drew of the truck orders? Well, we could place it off and say these are going to be tacos and these are going to be the drinks and do that same situation. All right, so it's x plus 4y. So let's just have the x be this. So there's the x plus the 4y is going to be the 4 drinks. So we'll go like this. And it's going to equal 11. Let's put an 11 over here. And the other one would be another x plus one of those y's is equal to 5. So that's how we could draw that out and sort that part out there. Okay? All right. Part 2. How could the sketch and reasoning about the equations lead them to a solution of the system? Well, similarly, if I did that canceling out, the crossing everything out like I did before, let's take away the x's. Let's take away one of these. And then I'm going to have here 3 of those y's. And if I cross out the 5 here, it's going to mean I'm going to have 5 gone from here. That means I'm left with 6. That means 6 here. So you can see that one of those y's would equal 2 when I do that division. But if I did the exact same thing with the equation, let's do that here. If I have x plus 4y equals 11, and I have x plus y equals 5. Let's just do the exact same work we just did a minute ago with that subtraction there. So x minus x is going to be a 0. 4y, remember this is a 1y. 4y minus 1y is going to be 3y. That's equal to 11 minus 5 is 6. Divide by 3, that y equals 2. Now we didn't finish this part. We have to go back and finish this part here. We would take this 2 and plug it in there, which is going to be the same process, taking this 2, plug it in there. So I'm going to do that work down here. If I did x plus 2 equals 5, well that's easy. I would know that x is equal to 3. And there would be my value. All right. D. Use diagrams or reasoning about equations to solve each system. All right, let's take a look. All right, so here we go. I like this way. We actually are going to call this method elimination method, where we eliminate some of these. Now, I know I didn't line this up very well, but if I did a 3x minus, remember this is like a 1x, 3x minus 1x is going to be 2x. Y minus y is going to give me that 0. And then 4 minus 5, that's a negative 1. Okay, so I have a 2x equals negative 1. If I divide by 2 and divide by 2, this means that x is equal to that negative half, just like that. So then I need to come back and actually plug this information back up in here. And so remember, this was a plain old x. It wasn't that 1x would be that confusing part. So if I do a minus a half plus y equals 5. Okay, so then I would come here. Well, let's just add the half over here and add the half over here. These actually cancel. Y would be equal to 5.5. And turns out those are our 2 solutions for that one. D2, we have 3x plus 2y equals 4, and x plus 2y equals 6. All right, same process. Whenever we notice we have 2 values that are identical in the two separate equations, that's when this elimination method works. So what we can do is just do a subtraction problem here. So remember, 3x minus that 1x is going to give us a 2x. 2y minus 2y is going to give me that plus 0. And then 4 minus 6 is going to be negative 2. So that would end up being a 2x equals negative 2. Divided by 2, divided by 2. X equals negative 1. Okay, so let's take that back and just plug it back in here. And it's the easiest one because it's a plain old x. So I'm left with a negative 1 plus 2y equals 6. So I'm going to add 1 here, add 1 here. It's going to cancel. 2y is equal to 7. Divided by 2, divided by 2. This is going to be y equals, this is going to end up being 7 divided by 2. It goes in 3.5 times, or 3.5. And those are our two values right there. All right, I hope that made sense. I hope it was pretty straightforward. I know it felt kind of quick, but the video's there to go back and watch. It's just another approach to solving these systems of equations. And I think that the graphing method's really good because it shows where they cross for the solution. We also have the situation where if I set the equations equal to each other, I can figure that out. But finally, this situation, we have this process of elimination. It will work if I have got the y values are going to be exactly the same or the x values are the same. Then you can do a subtraction problem and find that answer here. So let's take a look at the practice here. The ACE questions you're doing tonight, you are specifically working on 18 to 22. Let's take a look. All right, 18. On a hot summer day, Jay set up a lemonade stand. He kept track of how many glasses he sold on his phone. Here's the information. So the prices for a small glass is 35 cents. Prices for a large glass is 50 cents. He sold a total of 29 glasses and a total sale of $13.45. So if you remember from the previous lessons where we had the two scenarios back in investigation 1, you're going to need to come up and write two equations, one about the number of glasses sold and one about the amount of money made. Then you're going to solve those systems of equations. How many glasses were sold? How many large glasses were sold? So that's that one. And then 19 to 22, you use this information here. It's going to be just like the taco food truck situation, but they're going to be having different items for food. So I want you to write equations for both of the situations and then solve them to figure out what's the cost of the food item and the bag of chips or a drink. So you can see they're doing jambalaya here, sandwiches here, zucchini bread here, and apple pies here. All right, 8th grade. There's another one. Hope it's making some sense, and we'll catch you next time. All right, bye-bye.